Hi, thanks. I'm Lauren from Protocol Labs. I think actually, I don't know how advanced the group is. This might be a bit of intro, especially what Caro covered, but I'll go fast-ish to cover the basics for anyone who wants this or to watch it later. So Filecoin Network, why are we all here? What is it? It's the largest decentralized storage network in the world with over 1.4 exabytes of data on the chain and about 5 petabytes downloaded or onboarded every day. And you can see a nice upward slope to that growth. Global demand, this shows the presence of Filecoin throughout the world. You can see there's clusters in the US, Europe, East Asia, still to attack South America and Africa as globally, also a nice cluster in Australia as well. These are some featured clients. We've had quite a bit of traction with academics such as Berkeley, and Internet Archive is a big demonstrated onboarding of data onto Filecoin. A number of these other clients will dive into a couple examples. So Victor Chang Institute is a recent case study that's been getting quite a lot of press, if you've seen it. The challenge they had is that they generate a lot of data through research, and existing storage solutions don't provide that high level of data integrity where you can prove constantly that you're storing the data you said you'd store. So they wanted the strong guarantees of the Filecoin network. It was vitally important for their research, and that has resulted in 125 TIBs of cellular imaging and new research data being onboarded to Filecoin, particularly with DSS, which is one of our DSPs in Australia. UC Berkeley is another great example of using the Filecoin network. They were running dark matter experiments to produce massive data sets. And it was becoming so cost prohibitive that they wouldn't be able to keep storing the data at the level that they would want without leveraging Filecoin. With Filecoin, they've been able to store 400 TIBs of neutrino detector data and continue being able to use this data, which they would otherwise have lost for research purposes. Seal Storage is the one who's taken the lead on that engagement. And then Solana, another blockchain, is storing its state, had been storing its state in a centralized way, which is contrary to its mission. And now it is by storing data on Filecoin, they have Web3 native backup so people can find the chain state and it's not lost and it's available in a totally decentralized way. So now we have 500 TIBs of blockchain state data on Filecoin with new epochs being added as we go. This is also an interesting use case because the blockchain state data is this format called IPLD, which is native to Filecoin itself. I'll talk about how you actually get data onto Filecoin, and it is structured into this IPLD structure. So the fact that Solana already works that way is a great synthesis. Okay, so why are clients choosing Filecoin? People like cheap. It's 90% less expensive than traditional storage. So you offer that price comparison. Then there's having data durability. You can have, your entity, your data replicated across the world, as we saw. There's points of presence, and if you're getting attacked on your data center, there's other data centers available. Verifiability, the data is proven every day. So you know that your data is still there every day. If it's on a cloud like AWS, who knows if it's still there unless you go and retrieve it and check it. You can say where in the world you want your data stored, so you can satisfy different geographic requirements. And you can understand the carbon footprint. There's even a website you can go look at Filecoin Green and see how much energy is being used for the data storage. So that's the why, and how is actually data stored on Filecoin. So this is on the client side. When you're preparing the data, you take your cat JPEG and you have your original file, you break it into chunks, you add a header, and then you create what we call a car file. So the car file has this particular structure which helps then going and reading it in a certain way, and allows for like decentralized and distributed retrieval because it's broken up into these blocks which you can retrieve in parallel. You add zero padding to calculate basically a hash becomes the PCID, and then send off the CAR file to the storage provider, not with the padding. The padding was just for the calculation. There is software available that does these process for you, so you don't actually have to get into the weeds of doing it. There's Singularity, and then a really lightweight solution that's on GitHub that can be used even if you have minimal hardware is GoFill Data Prep. So now that we have a CAR file containing blocks, how do you actually get it onto Filecoin? So Boost is one option. There's also Venus. And what it does is Boost is run on the storage provider side. It takes in this CAR file and this data, and it makes the deal, and it says, okay, you've made this deal with this data, and this has these blocks. It stores that metadata locally on the SP, and it also then announces to the Interplanetary Network Indexer, the IPNI, that as an SP, I have this piece of data, this SID, so that when someone wants to go to retrieve it, they can seek from the IPNI and not have to know exactly which storage provider. Boost actually then hands off the data to Lotus. It's another component, and it seals the data and stores both a sealed copy and an unsealed copy. Software like Singularity or Spade will handle with the deal making so that every storage provider obviously doesn't have to implement this themselves. This is a little under the hood of how the current deal flow works, where the client uploads a CAR file to a web server and proposes a deal, and then the storage provider, the Boost instance, actually accepts the deal and downloads and pulls the file from that HTTP server, and then publishes the deal. Then the client can check, is the deal published? Coming soon is something called direct data onboarding, and this is targeted to be an NV21 this fall, where it actually gets rid of that announcement step. So basically, the data is imported by the SP, it's added to Lotus, it's indexed and announced without having to do what's called now published storage deal. And this is meant to make the onboarding much more flexible, and it will lead to more programmability of the storage systems, because this diagram may look a little complicated, but it actually is collapsing the steps, and there's fewer steps now involved in this next iteration. So how is data retrieved from Filecoin? Caro touched on this more in detail, but I'll just touch on it briefly, that there's in the Boost daemon itself, if you're running Boost, it's running GraphSync along with it. That had been like the original protocol for transfer of data on Filecoin. Recently, we've been moving away from that to adding now a Boost BitSwap component and a Boost HTTP component. Just a little why BitSwap, why care about this protocol at all? It's because of IPFS compatibility. IPFS nodes traditionally speak BitSwap, so then if a Filecoin node is running a BitSwap, it can actually just be a IPFS node, and the two can just talk to each other. And if you do an IPFS get and you have a Boost node running, you can get the data from the Boost node just as if it's a IPFS node. HTTP, I think we realized as we were developing in Protocol Labs that HTTP is just so built out and so mature and so tested and has so much, such an ecosystem around it of tools, that to not be relying on that in Filecoin, we were making it more difficult for ourselves. So we've now really leaned into having HTTP running, and so then people can add, just use all of the equipment and software that's available with HTTP. One of the easiest ways to actually function with retrievals right now is a client application called Lassie. And what this does is it abstracts all of the retrieval steps for you by actually doing the lookup to IPNI and then going and getting the data from either Boost Filecoin nodes or IPFS. It is completely agnostic to the two and will do things like fetch in parallel and get the data back and say where it came from. It can be interacted with in two modes. There's a CLI, so you can the semantics are literally Lassie fetch and your SID. And then there's a Go client library to be integrated if you have a Go app. And then the third way is also there's an HTTP daemon. So if you're using a non-Go app, you can just hit the HTTP server and then it will use Lassie to fetch data. It is taking advantage of all of the IPLD-like structures in Filecoin and the SIDS that is verifying the data. So it will actually verify the data you received is what you asked for. So there's no opportunity for the data provider to provide false data. And Lassie has everything you need to verify the content is exactly what you asked for. So that was meant as a general overview on the Filecoin and the onboarding and retrieval. There's deeper dives, I think either happened yesterday or will happen today on Singularity, Spade, and Boost, and I am going to be covering the Motion Filecoin REST API as well.